Okay, let's look at this problem. We've got a tower, kind of like an antenna tower, with a guy wire tied from point B to point A. The tension in the wire is 2,500 newtons. And the questions are to determine the components of the force acting on the bolt at point A and the angles defining the direction of the force. Okay, our approach is going to be to define a force vector that's equal to just the magnitude of the force vector, and it's pointing in the unit vector lambda direction, and lambda is going to be along this direction between A to B. So all we have to do is first find the direction from A to B. To define the unit vector lambda, we first have to write down the coordinates of the 2 points A and B. So let me first write the coordinates of point A. Now A, as you can see from the diagram, is going to be 40 meters in the x direction, plus 0 in the y direction, and then minus 30 in the z direction. While point B is going to be 0 in the x direction, plus 80 in the y direction, and plus 0 in the z direction. There, now we've got the 2 points A and B written down with the orthogonal components x, y, and z. From these we can construct the unit vector. Now remember, the unit vector has a length of 1. So what we want to do is compute the total distance between points A and B, and that'll be the quotient. And on the top we want the difference between A and B. So let me see, I'm going to write it. The lambda vector is going to be the AB vector divided by the distance from A to B. Now the AB vector, I can get just by subtracting the two. And I'll use the I hat, J hat, K hat notation. So first I've got minus 40, and this is in meters, in the I hat direction. Then I'm subtracting the B from 80, so it's the B from A, subtracting B from A, so it's 80 minus 0. So I've got plus 80 in the J hat direction. And then again I'm subtracting A from B, so I've got plus 30 in the K hat direction. Now for the total distance AB, I just take the square root of the sum of the squares. So I'm going to have minus 40 squared plus 80 squared plus 30 squared, and then I'm going to take the square root of that, and that comes out to be 94.3 meters. So now I can construct the lambda vector. You can see what it's going to be. It's minus 40 divided by 94.3 in the I hat direction, plus 80 divided by 94.3 in the J hat direction, plus 30 divided by 94.3 in the K hat direction. But what I really want, again, is the force vector. So remember the force vector over here, we had the magnitude of the force vector, which was 2,500 newtons, times lambda. So I'm just going to write that down here. We've got the magnitude, 2,500 newtons, and that's going to be divided by this AB, 94.3, that's in meters, and then these, each one are in meters. So then I'll multiply by this, minus 40 meters in the I-hat direction, plus 80 meters in the J-hat direction, plus 30 meters in the K-hat direction. So you can see once I do the multiply everything out, the meters will cancel out, and I'll just end up with force here. And then when I multiply this out here, what do we have? I'll just write it down. It ends up being minus 1,060 newtons in the I-hat direction, plus 2,120 newtons in the J-hat direction, plus 795 newtons in the K-hat direction. So there we go. We've written down the first part of the answer, which was what is the force components acting on the bolt. So we've got the components, the X component, the Y component, the Z component of the force acting on the bolt. The second component part of the question asked for the angles, and we can get these pretty much straight off here. So cos theta x is just going to be the X component of the force divided by the total force. That was 2,500 newtons. So it's just minus 1,060 divided by 2,500. And if we do the division, take the inverse of the cosine, we end up with an angle of 115.1 degrees. Similarly, you could do this for theta y, and you'll get 32 degrees. And when you do it for theta z, you'll get 71.5 degrees. There you go.